Alright. Oh. What's up, my dudes? Alright.
If only they could
Happy
see your
Halloween.
outfit
I know,
right
right?
now.
Do you believe in life after death?
Why don't you
Alright.
get the camera?
You're being
Huh?
taught by
You should get a camera.
I should get a camera. Actually, I was told I can't. I'm not supposed to have a camera. It's like the whole recording kids thing. It's weird.
Well,
Yoshi records kids.
Okay,
It goes viral.
Huh?
Yoshi records kids.
Anyway, all right, okay. Let's pretend that we know some math. All right. So we're taking a big stretch today. We're gonna pretend like we know some math. All right. So we're not taking this to 0. Okay. Can we directly plug in 0 for this? Say no.
Heck no.
No, because if I go raise it to the power 1 over 0, that's undefined. It's no real number, right?
Right.
Okay, so now, but think about it. Close to 0 is a really, really small number, right? Should be.
Yeah.
Because if I'm doing it like this, let's say it's going to be 1 over, so I'm going to go start with 1, right? That gives me 1.
I
Yes.
can't take you seriously, I'm sorry.
And I was looking at his hood and it's like an inside out Yoshi face. It's like scared
1
back.
over 0.5. What's that going to give me?
I got it.
All right, what's that going to give you? Come on.
2.
2, all right. So 1 over 0.1 is going to give me 1 over 0.01.
We get closer to 0. we get bigger
Okay,
numbers.
it's getting closer and closer to 0 from the right-hand side, isn't it?
Yeah.
So that means it's always going to be positive that I'm using here, right? Okay, so as I get my denominator closer and closer to 0, I keep getting larger and larger numbers, right? So where do you think this is going to end up going to? As I get close to 0 from the right-hand side, this is going to go up to what? Infinity. So my exponent here is going to say that I'm going to be going to infinity because of that. Okay? Now, with that same information, so I'm saying I'm going to raise it to infinity, but now if it's going to be 1 plus this number, okay, 1 plus, okay, so let's look at it. So let's take my 0.01. So is that going to add up to be more than 1? No matter what, it's always going to be more than 1, right? Since it's always going to be more than 1, that means my value is going to end up increasing, isn't it?
Yeah.
It's always going to be increasing, right? So because it keeps getting this right here, even though it's going to get smaller, it's still going to be 1, right?
Yeah.
But I'm still going to be taking it to a bigger and bigger power, so it's going to keep getting larger and larger every time. But with the same concept, if I multiply it and it would be, let's say it's going to be 1 minus 0.01, isn't that going to be less than 1? It's going to be less than 1. So if I multiply anything times 1, I get the same thing, right? And if I multiply more than 1, I get that same thing plus some. If I'm multiplying by less than 1, I get less than what I had the first time, right? So it's that 1 minus a little bit. So I'm taking off a little bit each time. So if it's less than 1, it's going to decrease. It's going to get smaller as I'm going. But since what we're doing right here is actually increasing, that means it's going to be basically saying I am taking this right here as it keeps going larger and larger and larger, right? Larger and larger and larger, that this is going to be infinity. Right? Basically. Because I'm eventually just going to get infinity out of it. I'm approaching 0 from the right-hand side. So all of this is going to lead me to getting bigger. So it's infinity to the infinity. Are you texting that right now?
Yep, I was just putting in my notes.
Infinity to the infinity.
Sure, infinity
Okay. So
I just put a
So
nice
the-
on my screen sideways.
because we're actually doing it like this, now this is going to keep getting bigger, right? It's going to keep getting bigger as I keep going up. So the limit rule or the L'Hopital's rule for this one, the indeterminate form, is going to be 1 to the infinity. So remember when I said that you have to actually state the indeterminate 0 over 0, infinity over infinity. This is another one which is going to be 1 to the infinity. Okay, I'm getting really, really, really close, and it's going to be 1, but it's going to be a little bit more than 1. And it's going to keep going up, 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 right? So that's what it's going to be. So we're going off to an indeterminate realm for this. So, because of that, I, stating this, could actually break it up. So I'm going to change it, and now this time I'm going to turn it into something else. I'm going to say that this now is going to be y equals 1 plus x to the 1 over x. Because to do my L'Hopital's rule, I need to actually have some type of thing that I could actually do this with, right? So, I don't like that power of 1 over x, right? So what would I do to both sides to get that power somewhere else? Natural log. So I'm going to ln both sides. So I'm going to ln. So I'm going to see ln of y is going to be equal to, what's going to happen to that power now? If I ln both, where's that ln going to go? Or where's that power going to go?
Down.
Yeah.
Not down,
Well, out front.
out front. So it's going to be 1 over x ln of 1 plus x, right?
Yeah.
Okay, so now from here, can we derivative here? Yeah, okay, so I'm going to get 1 over y, right?
Yeah.
1 over y, and this is going to be
dy dx.
dy dx is equal to, now take the derivative of, so let's take a look.
1 over.
Yeah, it's going to be a product off this.
Yeah.
Okay, it's a product, so that means it's going to be, the derivative of this is going to be
Negative 1 over x squared.
negative 1 over x squared ln of 1 plus x, right?
Yeah.
Plus, and so that's going to be 1 over x times, what's the derivative of the ln part? 1 over 1 plus x, and just so I'm keeping track, what was the derivative of the inside? 1. So I need to actually, yeah, so I it's not really necessary to show that, but I'm showing you to say that I actually did all parts of this. Okay, so now from here, let's go through, and I now have this. Now I can actually go ahead and try and do some of this now. So let's take a look. So it's going to be dy dx is equal to y, right? Quantity of negative 1 over x squared ln of 1 plus x plus 1 over x and times 1 over 1 plus x, right? And that is right here. So I have that much information right there, and let's go through and take care of that. What did I miss here? Oh, dang it. I did product instead of, I knew I was going to mess up on this one. That's why I was actually looking at my notes. Alright, so product rule was not necessary.
What?
You'll see why.
Oh, because if you multiply it.
Yeah, so if I multiply it out, so product rule wasn't necessary. Product rule actually caused
I was like, man, why does this seem so long? This is not, this is not what I did. All right, in my notes. All right, so if I rewrite this, isn't this ln of y equals ln of 1 plus x over x?
Yeah. Now that's going to be a lot easier, isn't it?
Yeah.
Okay, so now can I actually do L'Hopital's off this? Okay, so I could try to break this up, and I'd still get 0 over 0, right?
Mm-hmm.
Still get 0 over 0. So now I take the derivative, which is going to be 1 over y, L dy dx equals, now the derivative of the top. Okay, so it's going to be 1 over 1 plus x all over 1, right?
Yeah.
Okay, so now because of that, that's going to help me out. So I can go through and clean up a whole lot of that. So now, for right here, I know that this side right here, this side. So now this is going to be my limit, right? So it's the limit as x approaches 0 from the positive side. And then since I broke it up using my rules, right? Say yes.
Yeah.
I broke it up using the rules. And then from here, I got all of this, and that was equal to of this. I end up with what? So this is going to give me 1 over, so that would give me 1 over 1, which is just 1, right? Say yes.
Yeah.
So all this right here, if I do this of my function right here, right, I get 1. So let's replace this, because I still have an ln y here. I still have an ln y that I can't really take care of, and I can't get it out of it yet. So now if I'm doing this, I'm saying all this when x is 0 from the right hand side is going to come out to be 1, right? Yes?
Yes.
1 is the answer I'm getting. So when I plug in x, 1 is my y value, isn't it?
Yeah.
When I plug in x, 1 is the y value. So I know that I'm going to have ln of y is equal to 1. Okay, I couldn't actually get to this because this is not going to help me out yet. Because I need to know a value out of it. So I can't use this piece right here. I'm using this one from here to get my L'Hopital's rule. Now, I have an ln y. I don't want that no more. It did its purpose. It got to me where I needed to be, right? What could I do to get rid of that now? E both sides, right? So if I E both sides, what happens to my ln?
Goes away.
Goes away. So now I have y equals e to the first, right?
Yes.
So that whole thing comes out to my number is going to be e to the first, or just e. The reason why I went back to this is because this I picked this problem because this one goes back and forth. We had to ln to get to one side, but then I couldn't use the ln over here. I couldn't use this. I can't use this because if I were to plug that back in, right, on my derivative, that would still give me my issues, right? That would give me this issue, the same issue I have right here. And I can't have that because when I plug it back in, I can't cancel it anywhere. So I have an equal parts over here. I have equal parts right here. So when I was able to take the limit, remember, when we did this, it replaced it with this, right? Okay, and then I took the ln, and then I back over here. So that's where I got this. So I was able to get this here when I plug it back in, because this was supposed to be my ln y for all of this right over here. So at 0, I was able to plug it in to get 1 here. Everyone's completely lost and about ready to desk flip right now, right?
No.
Are we good?
Yeah.
Maybe, possibly. All right, we got some of these problems in the practice today, so I want to make sure they're. We got them all. Oh, yep, that was it. So you can go back and forth for these, okay? Especially on some weird ones where I have something to the infinity. I can't remember if that one is like specifically on the AP exam for the BC. I don't remember seeing one like that. It's usually 0 over 0 or infinity over infinity. Okay? All right, so we're gonna use the rest of the time to work on our assignments. Today's the last day to actually get in any of that stuff you owe me.